Welcome to the Bentley Systems training course to learn how to design concrete building structures in STAAD Pro. Over the next series of videos, we will show you a typical workflow for designing concrete building structures, which will include the process for creating load combinations and load envelopes. We will show you how to perform a P-delta analysis, and we will show you how to design concrete beams, columns, and slabs using the Reinforced Concrete Designer within STAAD Pro. In the STAAD Pro Reinforced Concrete Designer, designs are performed on members and slabs according to a set of rules defined in the appropriate concrete design code. The column geometry and loading have been successfully transferred from the STAAD Pro main application into the RC Designer. The other parameters, such as the concrete compressive strength and any reinforcement requirements, must be defined in the RC Designer through a column design brief. Once a design brief is defined, the design group can be created, which will instruct STAAD Pro which members to design and the applicable design brief which should be applied. After the design brief and group have been created for the columns, you are then ready to design the columns and review the results. To create my column design groups, I would go over to the Page Control area in the RC Designer and select the Groups and Briefs tab. Here from the Concrete Design Briefs dialog, I can create a new brief by clicking on the New Brief button. And my column design brief will be used to specify the column design parameters, including the design code and the appropriate material properties. I can name it anything I choose. I'm going to enter column design brief. I have a variety of codes to choose from. I'm going to select the ACI 31805, and I need to set the design type to column. Once I enter this preliminary information, I'm going to go ahead and click OK to create the brief, and then I'm going to be asked for a variety of parameters that will affect the column design, including material properties and the bar properties. For this particular model, I'm going to keep all of these concrete properties set as they are now, and then when I get down to the main bar information, I can specify a minimum and maximum bar size to be used in the design. I'm going to select a minimum bar size of number 5 and a maximum of number 9 for this particular exercise. I can also specify several pieces of information such as the strength of steel, my link bar size, and whether or not I want to use spiral or tied reinforcement for circular sections. After entering your material properties, I can enter my column parameters, including my effective length factors, and whether or not I want to include torsional effects. I'm going to keep everything here set to its default, and then I'm going to enter my member load case information. The last piece of information I need to specify for my column design brief are my member load cases. In the Member Load Cases tab, I shall select any of the load cases or combinations that I want included in the design of my concrete columns. For this model, I'm going to select all of my generated ACI load combinations. So I'm going to click on L7, and then I'm going to scroll down to the end of my load combinations, hold down the Shift and Control key, and highlight the last load combination. I can then use this single right arrow button to move all of those selected load combinations over to the selected window, which means that they will be used in the design of the columns. Once I've entered all of the parameters for my column design brief, I will go ahead and click OK, and now my brief definition is complete. After your column design brief is created, you are then ready to create a column design group, which can be done by selecting your column members and then associating it with the new brief you just created. To select our new members, I'm going to hold down my Control key and use my cursor to select each of the column members in my model. After I've selected all the members, I can go and click on the New Design Group button. I'm going to call this Column Design Group, and then I'm going to associate it with the column design brief. After you are done with that process, I can go ahead and click OK. And now my column design group is created, and I'm ready to move on to the next phase, which is designing the concrete columns and reviewing the results. To initiate the design of the concrete columns, I would want to go over to the page control area and select the Concrete Member tab, followed by the Design sub-tab. When I do that, automatically the Design Options dialog will appear, and all of the members within this column design group will automatically be selected. To start the design, I can go ahead and click on this Design button, and then you can see that all of the columns have been designed. I didn't get any warning messages, and all the designs are indicating that some main bars and shear reinforcing results have been obtained. Now, if after performing this design I found that some of the column sizes failed, maybe they were insufficiently sized for the results, what I'd want to do is go back to my main application. I would need to change those sizes and then reanalyze the model and return to the RC Designer. At this point, though, it looks like all of my columns were sized successfully, and I'm ready to review my results. Any of the main reinforcement results can be reviewed from the Main Layout tab in the Page Control area. Here I can select any column in the model that was included in that column design group, and here I can see how the reinforcement was laid out for those particular columns for the main bars. To review the shear reinforcement results, I could select the Shear Layout tab, and here I could see for any currently selected member how the shear design was performed. In addition, I do have a Results tab where I can review the main and shear reinforcement design results in a tabular format for all of the columns in this design group.